Hello, Algebra students. I hope everybody is doing well. We are continuing in Chapter 7, and we are now in Section 7-3. And what I'd like for you to be able to do by the end of this lesson is to multiply powers when they have the same bases, and to be able to raise a power to a power involving negatives, products, and fractions. So basically, can you use exponents when multiplying or raising them to another exponent? I'd first like to review a little bit from our previous lesson. So remember the rule. When multiplying powers, we are going to add the exponents. So let's just do a couple examples so we can see that in action once again. So we have to have common bases, and the directions say answer with positive exponents only. So in this first one, it is 1 to the 4th times 1 to the 3rd. Well, because the base 1 is common, that becomes 1 to the 4 plus 3, or 7. Well, 1 times itself 7 times is still 1. That does not mean 1 times 7. It means 1 times 1 times 1 times 1 times 1 times 1. 1, 2, 3, 4, 5, 6 times 1. And that equals 1 still. Okay, looking at the second example, I have -4 risen to the -3rd times -4 risen to the 10th. Well, the base is staying the same. I have -4. And then I have -3 and 10. Because I'm multiplying, I'm going to add exponents. So I'm going to raise it to the 7th, because -3 plus 10 is 7. I'm then going to input that into my calculator. So I'm going to make a parenthesis, input -4, and then raise it to the 7th power, and that is going to be -16,384. For the next one, I have 0.8 to the -1 times 0.8 to the -9. Well, 0.8 is still the base, and I have -1 plus -9, which is -10. Let's raise that, or put that into our calculator. So I'm putting parentheses around 0.8, and I'm raising it to the -10. And when I do that, I get 9.313. We'll just stop there. Now we have some variables in our problems. So we have -6z to the 5th times 9z to the -1. If we need to, we can reorganize this like -6 times 9 times z to the 5th times z to the -1. That might be easier for us to organize this. So I have -6 times 9, which is -54. And then I have z to the 5th and z to the -1. Well, 5 plus -1 is 4, so I'm going to have z to the 4th. Here I have 4j to the 4th times 7d squared times -2j to the -7th. Once again, I can reorganize this if that helps. So I can say 4 times 7 times -2 times j to the 4th times j to the -7th times d squared. And now I can combine stuff maybe a little bit easier. If I take 4 times 7 times -2, let's see here. 4 times 7 is 28. 28 times -2 is going to be -56. So I have -56. Then I have j to the 4th times j to the -7th. The j's have a common base, so I add the exponents, and that is j to the -3rd. And then d squared is still on the end. Remember, I don't like negative exponents, so this is going to reduce to, or simplify to, -56d squared over j to the 3rd. For my final problem, this negative is actually a -1 up front, so I have -1 times -5 times m squared times m times k to the -2. Negative 1 times negative 5 is positive 5. M squared times m is m to the third. And k to the negative 2 is still there. I want to get rid of my negative exponent by putting it on the opposite side of the fraction. Because there is no fraction, if I need to, I can write this over 1. And now I know, oh, that needs to go to the bottom. So this is going to be 5m cubed over k squared. So all of this is review from the previous lesson. Now we're going to kind of up the antics a little bit. We are going to use the concept of repeated multiplication to simplify a power raised to a power. For example, what if you had x to the fifth risen to the second power? Well, that means x to the fifth times x to the fifth. But then we know to just add exponents, which is the same thing here as multiplying that by 2. So I have x to the 10th. In other words, when raising a power to a power, you are going to multiply the exponents. When raising a power to a power, you multiply the exponents. Let's do a couple examples like that. Here I have n to the fourth. I have n to the fourth risen to the seventh. When I have a set of parentheses with an exponent in the middle, and then an exponent is also on those parentheses, that's raising a power to a power. So I'm going to take 4 times 7, which is n to the 28th. Here I have c to the third risen to the negative fifth. So I take 3 times negative 5, which is negative 15. So I have c to the negative 15. But I don't want a negative exponent, so that's going to become 1 over c to the 15th. Now, what I want you to be mindful of is when you do not see an exponent, there is a 1 there. So technically, there's an invisible exponent of 1 on that x squared, while this x to the 6th is risen to the negative 4. Each individual term gets multiplied out. So x squared risen to the first is still x squared times x to the 6th risen to the negative 4th is going to be x to the negative 24th. Now I need to multiply these two together, and my rules of multiplication is to add exponents. So this is becoming x to the negative 22 or 1 over x to the 22nd to make that exponent positive. On example 4, it's very similar to what we just did. There is an invisible 1 right here. So negative 2, or w to the negative 2 risen to the 1 is still w to the negative 2 times, and then I have w to the 5/3 risen to the third. Well, you still take 5/3 times 3. Don't let the fact that it's a fraction confuse you. It is still this number times this number. But when you take 5/3 times 3, it is 5, so I have w to the 5th. Now I have w to the negative 2nd times w to the 5th, which is going to be w to the 3rd. Now you're able to do this repeated multiplication even if there is a number in front of that. So notice how with all of these there was no big number in front of my terms, but down here that 4 is in front of the m squared. Well, let's talk about what this means. So if I have 4m squared to the third, that means 4m squared times 4m squared times 4m squared. An exponent tells you how many times to repeat multiplication. So this got multiplied by itself 3 times. If we reorganize that a little bit, that means 4 times 4 times 4 times m squared times m squared times m squared. Well, that's going to end up reducing to 64m to the 6th. So when raising a product to a power, multiply or raise each factor to the power. I'm actually going to say raise each factor to the power. I feel like that would be better. Raise each factor to the power and multiply the exponents. In other words, I'm going to raise 4 to the third power. That's what that's meaning there. Okay, let's look at some of our examples. We have 5x cubed squared. What that means is this. I have 5x cubed times 5x cubed. So 5 times 5 is 25. X cubed times x cubed is x to the 6th. 2z risen to the negative 4th. Okay, 2 is going to be risen to the negative 4th, and z is going to be risen to the negative 4th. I don't want negative exponents, so this is going to become 1 over 2 to the 4th z to the 4th. When I put 2 to the 4th into the calculator, I am going to get 16. So this is going to be 1 over 16 z to the 4th. Looking at my next example, I encourage you to take care of your powers of powers and then simplify after that. So I have x to the negative 2 risen to the second. Well, I take negative 2 times 2, and I get x to the negative 4th. I already just took care of this first part. Now let's look at the second part. This is going to be times 3 to the 4th times x to the 4th times y to the 20th. Every single term in this set of parentheses is going to get that 4. Now I can look and see if there's anything that I can simplify. So 3 risen to the 4th is going to be 81. So I took care of that. And then I have x to the negative 4th and x to the 4th. Well, when I add those exponents, they cancel. So I'm left with y to the 20th on the end of that expression. Here I have 3g to the 4th risen to the negative 2. Remember, everything gets risen to that negative 2. So this is going to be 3 to the negative 2, g to the negative 8. I got negative 8 because I took negative 2 and I multiplied it by 4. Let's make that so I do not have negative exponents. So this becomes 1 over 3 squared g to the 8th, which is equal to 1 over 9 g to the 8th. I have one more example on this page. Only this first expression is being risen to the power of 3, while this second part of the expression is being risen to the power of 2. So this first part becomes 6 to the 3rd times a to the 3rd times b to the 3rd. And then the second part is becoming 5 to the 2nd times a to the negative 6th. I got negative 6 by taking 2 times negative 3. Now I can combine any common variables that I have. So while those are different values, I can still find their numbers and still multiply them together. So 6 to the 3rd is 216 times 5 squared, which is 25, times, okay, I have a to the 3rd and a to the negative 6th. When I'm multiplying, I add exponents, so I got 3 and negative 6, so that's going to be a to the negative 3, and then times b cubed. I want to multiply these two numbers out, so that gets me 5,400, a to the negative 3rd, b to the 3rd. And the last thing I'm going to do is get rid of my negative exponent. So I'm going to get 5,400, b to the 3rd over a to the 3rd. We just have a half a page more of notes and then we will be done. What if the problem looks like division, or if it has a fraction, but it is still risen to an exponent? Well, this is going to work very, very similarly. Consider this. I have x over y to the 3rd. Well, that's the same thing as x over y times x over y times x over y, which means x times x times x over y times y times y, or x cubed over y cubed. So when I had a fraction and it was risen to a power, everything in the top and the bottom got risen to that power. So it says to raise a quotient to a power, raise the numerator and denominator both and simplify. Or I'm going to say How do I want to word that for you? I'm going to say multiply the numerator and denominator both, and then simplify. So let's put that into action and see what that looks like. This is 3 5ths risen to the third. That looks like this. 3 over 5 times 3 over 5 times 3 over 5. Well, when I do that, 3 times 3 times 3 is 27. 5 times 5 times 5 is 125. There's your answer. X over y to the fifth is the same thing as x over y times x over y times x over y times x over y times x over y. Well, that's x times x times x times x times x in the top, or x to the fifth. And in the bottom, it's going to be y to the fifth. Here, I have 1 over a to the third. Now, if I'm using my properties, I'm going to take this 3 and raise 1 to the third and raise a to the third. So this is 1 to the third over a to the third. But 1 to the third is just 1, because that's 1 times 1 times 1. So this is going to be 1 over a to the third. Looking at my next example, I have 3x over y risen to the fourth. Using your properties, every single term has to be risen to that exponent. So this is 3 to the fourth times x to the fourth over y to the fourth. But what is 3 to the fourth? 3 to the fourth is 81. So now I have 81 x to the fourth over y to the fourth. Continue following this pattern. When I raise a quotient to an exponent, that exponent kind of gets distributed to each term. So I have 8 to the 6th over n to the 30th, because n to the 5th risen to the 6th, I multiply exponents. Okay, so 8 to the 6th is going to be quite a number. Okay, let's see here. We have 262,144 over n to the 30th for that answer. For my last example, I have 5/4 risen to the -4. So that's 5 to the -4th over 4 to the -4th. I don't want negative exponents, so I'm switching what side of the fraction they're on. So that's 4 to the 4th over 5 to the 4th. Let's simplify that. So that's going to become 256 over 625. And that's our final solution. All right, we will be practicing with this more in class, but until then, have a good evening.